Let us understand phase. Phase is an angle. Phase is angle when we write the equations, SHM equations, like y is equal to r sine theta. This theta, that is argument of sine and cosine, that is the phase angle. To understand it better, first we have to understand that is when we say any SHM is projection of uniform circular motion on a plane, then it means if we have any SHM, we can also go back to represent it by what kind of a circular motion it is there, whose projection is this SHM. So it means if any kind of SHM we have, it can be a projection of uniform circular motion. For example, if we have a mass which is hanging by spring of spring constant k, and we know, let's say its time period is 2 pi under root m by k, this is the time period, and let's say it comes out to be 4 seconds, and this is vibrating within these limits. This is the mean position. We say this is the mean position, and this is one extreme, this is other extreme. So this is the amplitude, we call it as r. So it means if we wish to say that this is a projection of uniform circular motion, let's describe that circular motion whose projection is this SHM. If this is r, so amplitude is r, it means the body must be moving in a circle of radius r. That is, it should be radius r. This is the mean position, this matches with this mean position, right? This is radius r, so it means at any time the maximum displacement of mean position is r. So this kind of a circular motion is there. Also we know time period of this motion is suppose 4 seconds. So it means it goes from here, goes to the one extreme, comes back, comes over here, the other extreme, and once again reaches the mean position. And this whole journey, that is going up, coming back to the mean position, reaching the other extreme, and coming back to the mean position, this one oscillation that takes 4 seconds. So if we start with, we take this as 1, 2, 3 position, this is 4 position, at 5 it comes back. So if this motion is projection of this circular motion, so this should also complete one revolution in 4 seconds only. So if its time of oscillation is 4 seconds, it means this particle which is moving in this circle of radius r, that should also complete one circle, one revolution in 4 seconds. So it means omega we know that is theta by t. So theta for one revolution, it is 2 pi by t. T should be what? This completes one oscillation in 4 seconds. So this should complete one revolution in 4 seconds. So this omega should be theta by t. So from here we get the value of omega. So if we start our observation from here, let's say we see at t is equal to 0, if particle is over here, then it means the corresponding point should be over here. When this reaches over here, our particle which is revolving in a circle should reach over here, so the projection is over here. So that displacement of the mean position maximum, that is it has reached the amplitude. So this is 1, this is corresponds to position number 2. At 3 it is here, so at 3 it is here, 4 it is here, 5 once again comes back. So when it goes like this, it goes like this, it goes like this. When it is at this position, let's say when it is at this position, not this position, when it is at this position, this corresponds to this, not this, because right now it is going in the upward direction. So this corresponds to this, because right now this shadow will also moving in this direction. If it is over here, then the corresponding circular motion, this particle is over here, and we join it through the radius with the center. This angle, what it makes with the positive x-axis in the anti-clockwise direction, this theta angle, that is called phase. So for phase, what we do is, we understand where is the particle, we draw the corresponding circle, that is what kind of circular motion it is, we find the corresponding projection onto this, then we connect this point with the center. So this angle with the positive x-axis in the anti-clockwise direction is the phase angle, provided we are taking this SHM as projection of uniform circular motion on the y-axis. If there is a SHM which is along the x-axis, then we shall be taking angle with the y-axis. Let's take the example of once again of a mass which is hanging by spring of spring constant k, mass is m, and it is oscillating within the limits minus r to plus r. And we start our observation when it is at the mean position, and now it is going up. So over here it goes like this, momentarily comes to a stop, comes back, and over here and over here. So this one oscillation is completed. Let's see what is the phase angle at the different instants. At position number 1, at instant number 1, it is over here. So the angle, this angle is going to be equal to 0. So the phase angle is equal to 0. When it is at instant 2, it means it is over here. So we join this to the center. This line, this radius makes an angle of pi by 2 radian. This makes an angle of pi by 2 radian with the positive x-axis, because we are seeing this motion as a projection of uniform circular motion on the y-axis. So that's why this phase angle will be what is this angle with the positive x-axis. So instant 2, when the body is at instant 2, for that we'll say that is a phase angle, or phase is pi by 2 radian. When it reaches over here, that is from here to here, it has reached over here. So then we draw once again this line. The angle with this is going to be pi. So at 3, we say that is angle is pi radian. From here, when it reaches over here, that is, it means it has reached over here. So we say that is with this in the anti-clockwise direction, we say 3 pi by 2, or we can also say minus pi by 2. It is one and same thing. So after 4, once again it reaches over here. So we say that the angle which it makes is 2 pi radian or 0. It's one and same thing. Because after this, once again the oscillation repeats itself. These are periodic functions which repeat itself after 2 pi radians. It is not essential, that is all the time we have to start our observation from the mean position. What if we start our observation from this point, that is at t is equal to 0, this particle is here, this goes like this, goes down, reaches this extreme, and once again reaches over here. So this is instant number 1, this is instant number 2, this is 3, 4 and 5. It's anything you can say, 5, 6, any instances you can say. So instant number 1, that is at t is equal to 0, it is over here. Now at t is equal to 0, if we wish to find what is a phase like, so it means corresponding phase, and now it is going up, So there are 2 points. One is this point, the other is this point. Obviously, because right now, when we project our light from here, when this is going like this, the shadow will also be moving up. So this is the point which corresponds to t is equal to 0, and we join this point with the center. With this positive x-axis, this angle what it makes is called phase, and this is called also at initial phase. This is initial phase. All the time it is not necessary, it is not essential, that is we have to start our observation from mean position only. We may start our observation from here also, anywhere we can start our observation. If we start our observation not from the mean position but somewhere else, so then obviously there is going to be initial phase. So this is going to be initial phase. Now let's say we start our observation when this is at a distance, some distance from here. It goes like this, comes down, and once again it reaches here to repeat its motion. So when it is over here, so we see that this angle is going to be phi, that is initial phase. So at t is equal to 0, this point is here, and this radius, the angle it makes with the positive x-axis, that is the initial phase. At t, suppose at t is equal to t, it is over here. If it is over here, so it is over here. So it means from here to here, if we see this is y, so if it is moving with angular velocity omega, this particle is moving in the circle of radius r, then we know omega is equal to theta by t. So theta is equal to omega t. So in time t, this will subtend an angle that is omega t. So, but y, this y is going to be r and sine of this whole angle. So from the mean position, this distance is going to be y is equal to r sine omega t plus phi. This is called phase, argument of sine or cosine, that is called phase, and this is called initial phase. This is initial phase. And in case we started our observation from here, that is at t is equal to 0, if we start with the observation over here, it goes like this, goes like this, goes like this. So this is, so at t is equal to 0, it is here. So at t is equal to 0, it is here, and this angle, whether you say this angle or this angle, we'll say, let's say this angle is the positive x-axis, this comes out to minus phi. So at t is equal to 0, it is over here, and at t is equal to t, when it reaches over here, it means it reaches over here at t is equal to t. So this angle is going to be, theta is going to be omega t. Obviously, this particle is moving with angular velocity omega, t is equal to 0 over here, and it is moving with angular velocity omega. So in time t, theta is going to be omega t. From where to where? That is from here to here is going to be omega t. But what is the displacement of the mean position? That is only this much only. So what is that? So over here we will say y is equal to r sine total this thing minus this. That is omega t minus phi. Because we need only this angle only, What is this? This is total angle omega t, minus phi is this angle. So that's why this y, if this is r, this is this angle, so y is equal to r sine of this angle. That is r sine omega t minus phi. So let us take the displacement equation of SHM as y is equal to r sine omega t plus phi, where this omega t plus phi, that is the phase argument of sine is called the phase angle, and this phi is called the initial phase, and this is also known as epoch. And over here we have a body of mass m which is executing SHM in the vertical direction. This is the uniform circular motion whose projection is, we are getting this as SHM. So when we start our observation from here, so this particle is over here and it is obviously rotating with the angular velocity omega. Whatsoever is time period of this, from here we can get what is the angular velocity of this particle. That is omega is equal to theta by t is equal to 2 pi by t. Time period of this oscillation, we can put it over here, and from there we can find what should be the angular velocity of this particle whose projection makes this SHM. Now if we say, that is, if particle is at position number 1 at t is equal to 0, then what is the form this equation gets? This equation gets y is equal to r sine omega t at t is equal to 0. So this is omega into 0 plus phi. What is y at this instant when it is over here? The displacement of mean position is equal to 0. So it comes out to be 0 is equal to r sine, so this is 0 plus phi. So it means 0 is equal to sine phi. This implies phi is equal to 0 radian. If we start our observation, that is from the point number 2, if we start our observation at point number 2, that is, if start observation from instant 2, then let's see what is the equation like. Then y is once again equal to r sine omega t plus phi, where phi is the initial phase. If we start our observation at point number 2, we directly know that is the initial phase is going to be pi by 2 radian, that is the positive x-axis. This is going to make angle of pi by 2 radian, so initial phase should be pi by 2 radian. But let's see, that is mathematically it comes out to be same or not. So at t is equal to 0, it is over here. So we say y is equal to r sine omega at t is equal to 0. We are putting the initial condition. So this comes out to be 0 plus phi. If we are starting our observation from instant number 2, so over there y is equal to r only, that is amplitude only. So we put y is equal to r. So r is equal to r sine 0 plus phi. So it means r by r, 1 is equal to sine phi. So this implies phi is equal to pi by 2 radian. Also, if we intend to know, that is, what is the velocity, we know velocity function is r cos omega t plus phi. So over here we say v is equal to r cos omega t. Omega t, that is 0 plus phi is what? Pi by 2. V is equal to r cos pi by 2 is equal to 0. Obviously, when this is moving over here, then the projection of this onto the screen is equal to 0. Also, otherwise also, when it comes to the extreme, then the velocity, it momentarily comes to a stop. That is at both extremes, the velocity is equal to 0. We are getting velocity is equal to 0 only. So this way we can start from any instant. We can start from here, 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 here. Any instant we can start, and correspondingly we can see mathematically also over here we can see. And if we wish to directly find out what is the phase like, so from here whatsoever the motion is like this, draw a circle of the same amplitude, you know its omega, then find the corresponding, if this is a point like, find the corresponding point onto the circle, draw this line, that is radius, this angle which it makes with the positive x-axis, this is the phase angle, and depending upon, that is, from which point you are starting, you can also find the initial phase also.